Hi. Last lecture we explained how to find the inverse of Z transform using partial fraction. We started with simple roots. This lecture will explain how to find the inverse of Z transform using partial fraction when the roots are repeated. In this example, that's our polynomial b, and that's our polynomial a. So the first thing, we have to check the roots, but we should organize the polynomial a of z in descending order of z. So the highest order here, we see that's z bar 4. So we can write b of z is equal to, that will be the first element. Then we look for the z bar 3, that's 1, minus 5 z cubed, then 9 z square, then minus 7 z, and the last element plus 2. So that's the first step. Second step, we need to find the roots of this polynomial. As you see, it's just it's of order 4. It's hard to do it by hand. So you got two choices. It's either using the calculator or MATLAB. I prefer to use MATLAB. I will just use the command r equal roots and open bracket and another bracket for the data. I put here the coefficient of b of z in order. That's 1, minus 5, z, minus 7, 2. If you are missing any term, like for example, if you don't have 9z squared, it was missing all of it, then you replace this one by 0. Okay. When I run this one, I found that it gave me the result r was equal to 2, 1, 1, 1. These are the roots. So you have one simple root at 2, and then you got root 1 repeated 3 times. So what should we do? Well, it means that b of z could be written like that. Z minus 2 times z minus 1 cubed. So I will rewrite the expression x of z again. So 3z cubed minus 8z square plus 5z, and I have now the factor of the denominator. Before I do the partial fraction, we have to divide x of z by z. So x of z by z will be equal. Divide this by z, the top part, or the polynomial a of z. So you have 3z square minus 8z plus 5. Now I will do the third step for partial fraction. So you have z minus 2, put here constant c. Now this is a new thing. The new thing now, we have x minus 1 power 3. So how should we write this? Well, you start by z minus 1 cubed. You don't stop, and then you start to minimize the power of z minus 1, the square, till you reach the last one, and then you stop. You write here k1, k2, k3. Great. Now we need to find the constant c, k1, k2, k3. C will be found as we explained the last time. You look for the polynomial that we have it here, xz of z, and see the denominator is z minus 2, so do not use this term. You write everything except this term. So you will have 3 z squared minus 8z plus 5 and divide by what's left, z minus 1 cubed. And you substitute by z equal, all right, you know what value? Yes, when this one will be equal 0, at 2, at the ball equal 2. Then substitute in this expression, you'll find c is equal 1. Okay, now let's go and calculate k1. How you calculate k1? The denominator is z minus 1 cubed. So you should not include it in this expression. So when you have xz over z, this expression, just hide this one and just leave z minus 2 in the bottom. So k1 will be equal to the top part, no change. The bottom part, you don't write this term, z minus 1 cubed. No, you write what's left, z minus 2. Why? Because you're going to substitute by z equal 1. Because z minus 1 cubed, it's at pole equal 1. And if you have this one there, you will have 0 on the bottom, be a problem. So substitute and find k1. Well, let's just do that. When you put z equal 1, z squared equal 1 times 3 is equal 3 minus 8 plus 5. Sorry, there's a z here. So over z minus 2, z is equal 1. So you have 1 minus 2. The top part, that will be equal 0. So the result will be equal 0. We finish k1. You cannot substitute like we did in k1 to find k2 and k3. Only you can do it with the highest order here. But this one, there is expression. What you'll do, k2, you write this expression, 3z squared minus 8z plus 5 over z minus 2. The same expression you used to find k1, just write it here. Do not substitute by z equal 1 because you'll get the same result. Differentiate this expression. Find the first differentiation of this expression. And then after you find the differentiation, substitute by z equal 1. Okay? Well, let's just differentiate together this one. How we differentiate something like that? You square the bottom, z minus 2 squared. Then differentiate the top, 3z squared will be like 6z minus 8. That's differentiation. Multiplied by the bottom, z minus 2. Minus the top part, times the differentiation of the bottom, z equal 1. Now you found the differentiation. You can substitute by z equal 1 and see what is the result. I did that and I found z equal 2. You may work it out and see. The last expression, k3, what you'll do, go back to k1, write the same expression, 3z squared minus 8z plus 5 divided by z minus 2. Do not substitute by z equal 1. You should differentiate, but this time the second. And you divide here by 2, multiply by 1/2. Why I did that? I'm going to tell you now. Because we have expressed k, when you want to find any term like k1, k2, k3, nothing. K1 is not included. K1 is just to make the substitution, the first one. But k1, just look at k1 again. This is the whole thing here. But once you start to decrease the bar by 1, you start to differentiate. All right. So you want to find k2, k3, and so on. So to do that, let's just have a general formula here. We will say k m equal to 1 over m minus 1 vectorial, d, the differentiation of m minus 1, the expression here that we have. Z at the root that will work at ZL1, the root that's repeated at the root, say R, for example. In this case, R is equal 1. And what do you have here? Exactly as you did in K1. What is that? This is the whole expression, x of z over z multiplied by this root. So you can write it like that if you want to make it in general formula. That's why, I mean, I don't want to write this formula from the beginning. I recommend to do it like a numerical example. But this equal to x of z over z. That's the expression, just so. But you don't have this one. So what? How you get rid of this one? You multiply it by z minus 1 cube. But this is, I mean, in our case, the root is equal 1. What about if it's z minus r? In any other problem? So z minus r. Whatever is repeated here. For example, here it's repeated 3 times. Or any time. So it doesn't matter. Just, I mean, say n times, for example. And then you substitute at the value of this root. You see, I mean, that's why I don't like to write it here. I mean, I want to deduce it, but this is what's happening here. So when you observe here K3, which m is equal 3, then you have a vectorial m minus 1. You decrease this, and this is the vectorial, and the vectorial 2 is equal to. All right? And the second differentiation. So let's just, I mean, see what about if there is K4. If we don't have in this case, but just if you have K4, so you say 1 over vectorial 3, and then you differentiate the third differentiation to whatever you have here. You start from the beginning, right? And then you substitute by the at 1. But we don't have, just I'm telling you how we can get this one, all right? Well, so this one I calculated. K3 is equal minus 1. So we found K1, K2, K3, and C. So we'll go and substitute in the expression x of z over z. All right, so x, just will go up and down. Excuse me for that. So x of z over z is equal. If you remember, we have z minus 2. We have z minus 1 cubed. We have z minus 1 squared. Z minus 1, and then we'll stop. That's it, the last one. We know that this one, we got it already, is equal minus 1. Go backward. And this is equal to. And K1 is equal 0. And z minus 2, that was C equal 1. Okay. Now we'll go before the last step, we'll multiply the whole equation by z to get only x of z. So x of z is equal to z over z minus 2, 0, it's already gone, plus multiply this one, so 2 multiplied by z, z over z minus 1 square minus z over z minus 1. It's ready now to find the equivalent x of n. How you do that? Go to the table. The table shows you what the equivalent. This one already, I mean, we know that we're going to use all the time. That's the constant. Z over z minus a will be a power n. So that will be 2 power n un. Un, the step. Let's look for this. This one from the table is equal n un. This is the ramp. And you got the constant 2. You put it there. And this one is the unit step, un, and you have minus sign. Add them together, so the function is equal xn, 2 to the power of n, plus 2 times n, minus 1, this is u, right? All common with un. So that's the answer. Okay. There is a nice thing. You can get this answer using MATLAB. So I want to show you how you are going to use MATLAB to find the inverse transform. It's very simple. You remember you are going to use the sims because you want to find the expression, and the variable will be z that you're going to use. Let's write f capital. That means the z transform, and you write the main function for the expression for xz. This one you just write in MATLAB. All right, let me show you and check. Please try to write the program. The top part you have bracket here. It was like 3 times z cubed minus 8 times z squared plus 5 times z divided by, I'm going to continue here because I mean you just, but you should continue in MATLAB in the same line. Z to the power 4 minus 5 times z to the power 3 plus 9 times z squared minus 7 times z plus 2. That's the expression. Now we want to find f small. So f small equal inverse z trans open bracket f capital. It will take this expression. Don't put semicolon. Here semicolon because you don't want to print the expression. If you want, you go ahead, leave the semicolon and then print it out. You'll find you get the same expression. Okay. There is another thing I want to say. Well, sometimes, I mean, you need to find the constant C, K1, K2, K3 using MATLAB. There is a function in MATLAB. It can give you these constants C and K1, K2, K3. The function is called residue. Let's show you how you can do it using MATLAB for the residue. Okay. Let me just write first, I mean, x of z, if the expression like that, and the question is find the residue. It's equal to 3 z to the power 3 minus 8 z squared plus 5z divided by, I'm just writing the same expression we started the problem. Show you how to find the residue of partial fraction. Z squared minus 7z plus 2. Now, I know that I'm going to find partial fraction C, K1, K2, K3 in the problem. So you have to express this polynomial B and A in MATLAB. Don't use sims because you are going to evaluate. To evaluate the residue, you are going to find the numerical answer. So in this case, you don't use sims. Sims only for expression. Then the first command in MATLAB, write the polynomial B. 3, the coefficient 3. Remember, it had to be ascending order, and if you're missing a coefficient, put 0. 5. Oh, by the way, you should divide it by z. If you divide it by z, it will decrease everything by 1 because you find the expression for x of z over z. That's the polynomial B. A. You have 1 minus 5, 9 minus 7, 2. You can put semicolon. You don't want to print, except if you want to print it to check that you wrote the right expression. All right. Now what you do? You write this expression R B. You are free, by the way, to choose anything. You can write A, B, C, D, whatever. But this is R means the root, B the poles, equal. And then write this, very important, residue. R-E-S-I-D-U-E, bracket B, A, and that's it, and run the program. You are going to get two results, one for R and one for B. R, it will give you 1, minus 1, 2, 0. And you will find in bold in this order 2, 1, 1, 1. So obviously that's the residue 1 when the ball is equal to. What does it mean? When you have z minus 2, that's the mean ball 2, the coefficient that we found c equal 1, the residue is equal 1, call it residue. Okay, what about that? Okay, this, you start from the last one that's corresponding to z minus 1, the last one, and the coefficient is 0. If you remember, we got 0 for K1. There, yes, that's K1, we got 0. All right, and that's K1. K1 is the residue for z minus 1 cubed. Do you write it in MATLAB? The last one, not the first one as we did. Do you make it the other order? So this is z minus 1 cubed, and that will be your K1 is equal to 0. And this one will be z minus 1 square, and that will be your K2. And then will be z minus 1, and that will be K3 is equal minus 1. So that's how to find the residue of a partial fraction. Okay, I think that's good. Only I have to tell you about one observation intentionally I did. Observe that you found K1 is equal 0. You know what does it mean? Let's go there and see what you have. When we reduce this equation, x of z over z, that's what we got. The top part is equal 3z squared minus 8z plus 5. The bottom, z minus 2, z minus 1 cubed. Let me write it here and observe that. So x of z over z was found to be the following: 3z squared minus 8z plus 5. And the bottom, it was z minus 2, z minus 1 cubed. Well, if you analyze this one, you can find the roots of 3z squared minus 8z plus 5. If you want to do it, you can do it in MATLAB to find the roots of this one. I advise you to check. I'm going to do it now in MATLAB. I have MATLAB with me. I'll write roots. Sorry, roots. And you open here the polynomial that you'll find is 3 minus 8, 5, and try to find the roots. I'll just do it now. Check. Why I'm doing that? Because I got 0 for so I want to know why. All right. So you will find out that the roots of this one 1.667 and 1. What does it mean? It means that you can factor the top part b. You can write it like that: z minus 1, z minus 1.667. All right. So what does it mean? It means if you put this on the z minus 1 cube, z minus 2, you will find this cancel, this one will be 2, and that's why you'll not find the third one. I just want to tell you about the observation. If you ask me, can you do that? You can do that, but you don't have to bother yourself, because if you continue and you work, you'll find get 0 and you get the right result. But I'm just trying to explain to you why I did that. I advise you to do that and do the example in the handout so to practice. If you have any question, please don't hesitate to ask me. And we'll still have another lecture for complex roots. See you then.